Hello, Secondary Math 1 students. Time for another test. Here's the review. Let's go over it. This is Systems of Equations is this unit. Let's go over this review to help you prepare for the test. Question number 1 begins by saying what's the solution to this system? The very first thing we covered was we can graph these, and where they cross is our solution. This one already is graphed for us, so it makes it pretty simple. We're going to go 3, -2. It's an XY pair. Therefore, that becomes our answer. Number 2 says which system of equations is graphed. So this time, I know that's the answer, but we want to know which equations matches those lines. So to do this, what I look for is if I take this line right here, for instance, I'm going to look where it crosses the y-axis at 2, so I know it's going to end in +2. That could be a couple options in here. And then I'm going to count the rise and the run. This looks like it's going down 1, right 1, which tells me I have a -1x slope +2. So I'm looking for that. I know it's negative because it falls. So I'm looking for that. That's leading me right here. I wonder if the next one will cross at 5. 1, 2, 3, 4, 5, and it does. And then hopefully it's a slope of 2. So from here to there, I'm rising 2 and running 1. So that matches this one. So I'm thinking those are my two equations. I'm looking for the intercepts and the slopes. This is slope-intercept form. So those are the two equations of those two lines. Number 3. 3 is asking which inequality is represented by the graph. Same idea. I'm looking for the one intercept, which is going to lead me to 3 possible answers. So now I've got to kind of check out the slope. I know this is a negative slope. That's positive. That's positive. That leads me to this one already. That's going to be down 1, right 1 is what that's saying. That's my slope. The greater than or equal tells me what we've talked about is the shading is going away from 0, 0. 0, 0 is a nice little point to test. I can rewrite that equation like this, plugging in 0 for x and y. 0 plus 1 is 1. Is 0 greater than 1? That's a false statement. That tells me we're shading away from 0, 0, and that's why the shade happens up here. That's why this becomes a great equation for that one. Number 4, which system of inequalities is graphed? Our multiple choice answers. Okay, so this is similar to the other one we did, but now we got to be concerned about the shading. So if I'm doing this one, again, I'm seeing this dotted line is crossing at 1 on the y-axis, so I know it's going to end in +1. And then I'm looking where it crosses at a couple nice corners. So for instance, from there to there. And I'm going to count that rise and that run. So 1, 2, 3, and 1. This is a negative slope because it's falling to the right. This is our equation. Now, since it's shading to the left, 0, 0 is in that shaded area. So it has to be true. So if I put 0 in for x and y, I need an inequality right here, right? So 0 plus 1 is 1. So I need this to be true. So what inequality would I put here to make this true? 1 is bigger than 0, so I would show that it's bigger than 0. It's a dotted line, so I'm not going to put an equal under it. That would become my equation for the dotted line. Same for this other line. It's crossing at -1, so its equation is going to end with -1. Its slope, if I choose a couple points, is a rise of 1 and a run of 2. This is positive this time, so here is its equation. I just need the inequality. We're shading above the line. 0, 0 is part of the solution set, so again, if I plug in zeros, I need this to be true. And I would say that 0 is greater than -1, so I'm going to put that as my solution. These would be the correct answers right there. And as I look at my multiple choice answer choices, it looks as though 1/2 minus x, looks like it's going to be that one right there, okay? Number 5, which system of inequalities is graphed? Another one just like we did, only this time they're in standard form, okay? There's a couple ways we can handle this. Standard form, I'm looking for intercepts. If I take this solid line right here, it's crossing at 5 on the y-axis and crossing at 1, 2, 3, 4, 5 on the x-axis. Those are the intercepts, okay? Now, when I'm looking at my equations, if I take this first one, to find intercepts, I eliminate the x. I put a 0 in for x, right? Because 0 something is my y-intercept. And then right here, if I put 0 in, then I'm left with y is 5. that satisfies that. If I put a 0 in for y, then I have x is 5, and that satisfies that. This is an appropriate equation for that line. The same needs to hold true for the dotted line. It crosses at 2 and 1, 2, 3, 4 at -4. Those are the two intercepts. If I eliminate the x, am I going to get -4? And indeed I will, because to solve this I need to get rid of the negative, so I divide by -1, and then I would get -4 as my answer. So that's a good intercept. And then if I eliminate the y and divide by 2, x is 2. So those are the great two. That's standard form, finding intercepts to graph the lines. Okay. Number 6. Here it is. Solve the system by substitution. Our first answer, this one's kind of a simple one because our first answer is already given. It's 2. So I'm looking, I already know it's going to be that one. That's the only one that has 2 as a y, right? To find x, I'm going to substitute that 2 in for y. So it reads 2x minus 3 times y equals 8, but y is 2. So 2x minus 6 equals 8. If I add 6, I get 2x equals 14. If I divide by 2, then x is 7, and that's how we get the 7. So there's that one. Number 7 is another substitution problem. We're looking for an equation solved for y. This one is. I'm going to take that information and substitute it or replace that y with -3x. So it reads 6x minus 9 equals -3x. And then I can simply solve for x. I've got a 9 here. I think I'm going to take this x and get rid of it. And then I'll take care of it over here. And that leaves me with this. And then I'm going to divide by -9. Which gets me x and 1. So I know x is 1. That's going to lead me right here. That says y is 1. So if x is 1, I can throw that back in right here. That's another substitution. What's -3 times 1? And that's -3. That's where the -3 comes from.